Hi everyone. In this video we're going to discuss about the multiplication theorem of probability. So to say about the multiplication theorem of probability, we use the conditional probability which we have discussed in the earlier video. So coming to the multiplication theorem of probability, for two events A and B, probability of A intersection B is equal to probability of A into probability of B given A, where probability of A is greater than 0, and also probability of A intersection B is equal to probability of B into probability of A given B, where probability of B is greater than 0. So this is a statement of the multiplication theorem of probability, where if there are two events A and B, and the probability of A intersection B can be written in these two ways, where either as a conditional probability of A given B or as a conditional probability of B given A. So here the probability of B given A is a conditional probability of the occurrence of B when the event A has already occurred, and similarly probability of A given B is the conditional probability of the occurrence of event A when the event B has already occurred. So we are writing this probability of A intersection B in terms of probability of B given A and probability of A given B. So now we are coming to the proof. So for the proof, we use some of the usual notations that we are familiar with. That is, the probability of A is written as n of A divided by n of S, and probability of B is equal to n of B divided by n of S, where n of A is the number of events or the number of possible outcomes of event A, and n of S is the number of events in the sample space, and probability of B is equal to n of B divided by n of S, where n is the number of possible outcomes of event B, and all the possible outcomes in the sample space is given as n of S. And similarly, probability of A intersection B can be written as n of A intersection B divided by n of S. So we denote this set of equations, this equation, as star or the asterisk symbol. So now we use the conditional event A given B. For the probability of A given B, we can write it as probability of we have already discussed in the previous video that the conditional distribution of A given B can be written as n of A given A intersection B divided by n of B. So this is the formal definition of the conditional probability or the conditional probability of A given B. Therefore, we can rewrite this asterisk, this equation given in asterisk, that is the probability of A intersection B, as n of A intersection B divided by n of S into n of B by n of B. So we are going to multiply this equation in the asterisk symbol by n of B divided by n of B. So if we are multiplying a value that is multiplied and divided by the same value, then it remains the same. So for this equation, for this asterisk symbol, we have rewritten as n of A intersection B by n of S into n of B by n of B. So from here, I'm going to rearrange this, where I'm going to write, I'm going to club n of A intersection B divided by n of B into n of B by n of S. So I'm just rewriting, or I'm just rearranging what I have written in the previous one. So from here, we know n of A intersection B divided by n of B can be written as probability of A given B, and n of B by n of S can be written as probability of B. So from there, we get probability of A intersection B as probability of A given B into probability of B. Similarly, we can write probability of A intersection B in terms of probability of B given A into probability of B. So it's the same procedure and such a simple proof for the multiplication theorem of probability. So this is how we get the multiplication theorem of probability, where we can write probability of A intersection B in terms of the conditional probabilities in both the conditional probabilities, that is the conditional probability of A given B and the conditional probability of B given A. Now we shall discuss some remarks. That is, we have said that from the conditional distribution or from the multiplication theorem, we can write probability of A intersection B in terms of the conditional probabilities. So using that equation, we can find the conditional probabilities from this terms of the intersection, the A intersection B and probability of B. So if we know the probability of A intersection B and the probability of A, then we can find the conditional probability of B given A. And similarly, if we know the intersection A intersection B, the probability of A intersection B and probability of B, then we can find the probability of A given B. So thus the conditional probabilities are defined if and only if probability of A is not equal to 0 and probability of B is not equal to 0. Why? Because when we define the probability of B given A, or when we define the probability of A given B, in the denominator we have probability of A in the first case and probability of B in the second case, and that is a fraction. So if the denominator part is a 0 value, then that is not defined. So this exists. These conditional probabilities are defined, or the conditional probabilities exist if and only if probability of A is not equal to 0 and probability of B is not equal to 0. Now, if we know probability of B is greater than 0, then we can say that the probability of A given B is less than or equal to probability of A. Because probability of A given B is the conditional probability of the event A such that the event B has already occurred. So we know the event B has already occurred. So the sample space, the total sample space has reduced to an set B, or something. There is some restriction on that. There is a condition or a restriction, and the unrestricted probability of A will be a much more larger value, or sometimes they equal to it. So we can say if probability of B is greater than 0, that is, for the conditional probability exists, then probability of A given B is less than or equal to probability of A. So I hope this video was useful. It's on multiplication theorem of probability, and for more clarifications of the conditional distribution, you can watch the previous video. Thank you.